Yeah, so again, this function should use this get char as we kind of used last time. So every time you want to move to a new position, you just use the get char to get a new character. And then we knowing because then afterwards will be the number, right? Because inside this while loop. We basically just append this value into our n, right? Every time we append a new digit, we multiply the original value by 10 and adding this character minus character 0 after, right? Again, the only important thing is you get this power multiplied by 10 every time you read a digit. So later on, you can use this power here to move this decimal point back to the position. Some of you, when you do the test wrong, let's say your input is 12.3, your output might be 12.300000001 or something like that, because that has some round-off error because of this operation here, which is okay, which is typical. If you really want to show a number precisely, that means you want to record how many digits you have read, and while you print it out, you only show the first few digits of it. Yeah, you can do that. All right, so let's move on. The pointer and array essentially are very, very similar, or I would say array is largely rely on the pointer to be working. Okay, so later on we can see how we can convert or change the existing code using array by using pointer instead. Actually, this is what the compiler will do. So whenever you're using an array in your code, the compiler will convert it into the pointer version before move on. All right. So this is how we declare an array, as we have talked about. So yeah, if you have a question about the previous exercise, please raise your hand. Otherwise, please keep quiet. All right. Yeah. Again, if you have any question about the previous exercise, yeah, let me know. Okay. Do you have any question? Yeah. You're good? Yeah, you should copy from our template file rather than copy from our slides, because the slides I only shows the part of the code. You cannot run this function. All right. The template file I provide in our shared file will have everything inside. Not this file. Not this file. Okay, go back to our folder. Yeah, so go 9-1. Okay, now 9-2. All right. All right, so this is how we declare an array of size of 10, right? Remember, if we're going to call a particular number from this array, we'll use A0, A1, A2, so on and so forth, right? So effectively, we can do the same using this pointer, right? So let's say we have a pointer as like a PA, which is pointing at array A, right? Pointer pointing at array A. And first of all, we want to get address of our array by using this at A0, because this is how you get address of array. You are getting the first address of the whole array. Yeah. So now we got this address. Then using this address, we can get a value from this first number in our array, right? So if we can use the PA to point out at first position in our array, or we can use our PA plus I to access the value of AI. Right? For example, yeah. Sorry, what?
We cannot use only the name of the array.
Only the name of, we can, yeah, but just for getting the address of it. Yes, yeah, you can do that. Yeah, I will show you that later. Yeah. But here, just want to show you how to index this array, right? If we want to access this array using the pointer, so the 0 position first spot in your array is, you can get it through this star PA, right? And then I position can get from star bracket PA plus I. This is why I show you that example earlier. I say, okay, if you're adding increments a certain value of this pointer, then you're using this star key to get the value of it. You're not getting the value of the original, not the original address, rather than the address after I positions front. Okay. This is why it's very important for us to declare the type of pointer. All right, because if it's an integer, let's say every integer contains one byte in our memory, right? For example, in this case, we know this is every memory store one integer, right? So this is A0, A1, A2, right? Let's assume that's the array. Now, if we have this pointer pointing at the first position, now we say pointer plus 1, it will move to here, right? So increment by 1. This is for the case of integer. Let's say if we're storing double takes more memory than integer. So let's say double actually is, every double will takes 2 memory address. Like this is one double, and this is another double value. So at the beginning, you're storing this value, right? And then you say pointer plus 1, then we should jump to here. Because as node, the pointer is pointing at the double, it will increment accordingly. Okay. So here is some example. So we can have those two explanations equal to each other, right? So the array position, the value in I position in the array, address of that position equals to the position of this first one increment by I position. So essentially, this is telling us by increment your initial pointer, you're moving along with your array forward. Okay. So let's look at an example to better understand this one. Let's say we wanted to create a simple storage allocator, which is use a large array called allocate buffer, allocate buff, right? Buffer. What that actually do is whenever we needed to create a new array, we will try to store it inside our buffer, right? In order to do that, we're going to create two functions, which is called, one is called allo, the other is free. So what allo is do is it will assign an address in our memory to the new array. All right, let's go back to our example here. Let's say we allocate this area in our memory Okay, we say this is for storing our array. This is our array buffer. So every number every array we're going to create will in those 3 columns, for example. All right, so let me mark them with some color. All right, so this is a space we'll store all the new arrays. All right. So now, if we want to create an array, and we know the size of it is 10, length of 10. So we count how many space we have in our allocate space. We see, okay, we have 10, right? Because we know where the beginning is, and we added that by the size of the array we need. We know where the end is. As long as the end is still smaller than the size of our buffer, we say, okay, we have enough space. So this is effectively what this allocate function do. So it only check if you have enough space. So if so, we will move our pointer to this new position. So this will be the starting point of the next array, right? So let's say we will effectively mark this area for the first array, right? Next time a new array comes, it will trying to occupy more spaces. All right, so let's simplify this case. Let's don't worry about those 2 row for now. Let's say this is only the buffer, it's just only 1 column. All right. So next time we want to allocate another 8 or 10 spot in our buffer, right? However, our buffer has only 15 space in total. That means we only have 5 left, right? So we know where our original location is. We know how large our buffer is. That's 15 total. So when the next call comes, let's say I'm going to create a new array of size of 10, it will reject it because we're running out of the space. All right, so this is what the allocate function do. And the other function is called free. The free function is effectively just move the starting point backwards by n amount of position. So we assume we always remove backwards. Like there's no way we can only remove this array without changing the next array. That's because our algorithm is very simple. Just as an example, right? Almost like a stack. All right. So understanding what we're going to do, let's look at those functions here. So first of all, we allocate we define a size of 1000 for our buffer, right? We're creating this buffer in our memory. Note that here we're using static, right? Static means this variable or array only accessible inside this file, right? Also, we have created a pointer, okay? And the pointer was pointing at the beginning of this space first, right? The starting point of this space. Now, once we have a new request, we want to allocate n characters, right? In that case, it's n inside, and it will do the calculation as what I just told you. Basically, it tests if we have enough space in this buffer. If so, we will move our pointer by n space. So it's moving towards the new location and reserve the previous point to the array we're going to create. Otherwise, if there's not enough space, it will return not enough. All right. So that's essentially what I just showed you earlier. Free is again more straightforward. Is effectively only set our pointer to a given pointer. That's it. Like if you set it to the original value of this point, that's clear out everything in our buffer effectively. Or if you assign to something else, depends. But you want to make sure that the pointer is within our buffer range. as long as it's in between, in our buffer space, you can set that. Right, so we have already shows a lot of similarity between pointer and array. There's one difference. As we said, we can increment the pointer by having PA++, right? However, we cannot increment an array, right? We cannot say array A++. We cannot do that. Or we cannot create an array from the pointer. We can create a pointer from an array. This is your question, right? So you say, yeah, we can directly create this pointer from the array instead of like the assign A0, right? We can do that. But we cannot do the reversely. We cannot create an array from the pointer. Yeah. So here is another example of function which is getting the length of input string. All right, so we have something similar before. This time, what we're doing is using array. So we're using the pointer of the beginning of this string array, and then we keep increment the pointer by 1 and 1 until we're reaching the end of line symbol, right? And then we return this number back. So the difference here is because we're sending this array pointer here, right? This pointer itself is a copy of this original address. When we're doing this increments, okay, increments here, afterwards this S will no longer pointing at the beginning of the string, rather it's pointing at the end of the string, right? However, this is a copy that doesn't really make any change to the original pointer, right? The original pointer is still pointing at the beginning of the string. We can also, using the pointer, we can have flexibility to send partial array, right? Let's say instead of sending at A0, we're sending at A2. That's skipping the first two numbers in our array and send the rest of them to the function, right? Or we can use this way. This is increment this array by 2 positions. This is alternative way to do the same thing. Yeah, so this is how we use it on the top, how we use array in the function, and the bottom, how we use the pointer in a function. They're very similar to each other and almost interchangeable to each other. All right, so now let's look at a specific case, which is array of characters, right? A special type of array, which is array of characters. We want to clarify there are a few things. First of all, we can pass this array of character as argument to functions, right? So here we put this hello world in between this double quote, and then pass this is actually an array, right? And we pass it to the function. Alternatively, we can create this pointer, right, and assign this array to this array and send this pointer to the function as well. So now let's try that on string copy. As earlier I mentioned that by default, when we sending a array to a function, we're effectively sending the address of it. So we're not making a copy of it. However, sometimes we do want to make a copy of a string or array, right? If we do want to do that, let's say we want something like this, but however, this operation will not create a copy of a new, or let's say the T is the array. We assign S to this T array is not giving us a copy of this array. Rather, it's giving only a copy of the address of it, right? So if we want to create a copy of it, we want to make a specific function for it. Okay, in this case, we call it string copy, passing to array, right? This is a array version. So we passing to array, and then we have this while loop, and we keep assigning this T array to the S array until we reaching this end of string symbol, right? So this function will effectively help us to copy one string to another. So let's look at what is the pointer version of this function. So the pointer version of it, this is the first way looking at it. So first of all, we're sending two pointer instead of two array. And then we keep assigning this pointer value to another pointer value and increment them one by one, right? Increment the position of this pointer every time until we reaching the end of line symbol. Okay. Since we have talked about a condensed way to express the increments before, so I assume you can naturally think about, oh, maybe actually I can move those two plus sign to here after here, right? No? Okay, you can try by making it this. Yeah, so this is a more elegant solution, all right, because this is a little bit simpler and quicker to read. This is actually why we have those special plus plus operations in C. So a lot of time you have to increment your pointer one by one to process the entire array. This makes things very, very convenient. So again, those two versions are equal, right? So you assign them up and then increment after are effectively the same as this way, right? Because the plus sign is after this value. So this is a more condensed version of it. However, we can make this code even more condensed by making it in this way. All right, so this is the final version, the most simplest method. So in this case, you notice that we are not comparing it to the new symbol anymore, right? Previously, we want to determine if that's the end of the string, right? And we're getting rid of this part. This is because the end of string symbol is a /0. This symbol will be treated as the same as 0, which means false. So when the while, okay, in this case, when the T is the end of the line symbol and after being assigned to the S, this end of the line symbol will also terminate our while loop because that's a /0, which equal to 0 or equal to false in our case. Okay, so the other example we can look at is string comparison, which will compare two strings. Here is the array version of it. So very similar to the assignment, rather than assign a value back and forth, we're comparing them, right? So we have this comparison operation in the middle until we reaching the end of the string. If that's the case, if we reach the end of string, we'll return 0, means those two strings are the same. Otherwise, we will compare those two characters, okay, by -1, one minus another one. They will compare them. So now we convert this version. Okay, this is an array version again, and we'll convert it into the pointer version of the code. We can notice that the code is a little bit shorter, right? We're sending those two pointer inside the function, and we compare them and keep incrementing them, using a for loop. So using the for loop, we can increment them and doing compare at the same time. Well, actually, even using the while loop, you can still do that, right? You can have the star s plus plus equal star t plus plus. Can do something like that as well. Then we see if it's the line end of the string. In that case, return 0. Otherwise, return this difference is in the value. So again, this increment and decrement with a pointer makes things very, very convenient when you're handling a large size of array. You can have them either before or after the pointer. Okay, let's look at another example, which is to write a pointer version of function concatenate. So this function, what it do is it will add up two strings together. So one is string is hello, the other string is the world. So we want to add them up and modify the s to the combined version of those two strings. All right. So here is a version again in array form. So what do you want to do here is to convert this into a string, a pointer version to achieve the same functionality. All right, please go ahead. This is exercise 9.2, 9-2, and this is the array version, and you want to convert it into pointer version. If you just break it down, there's two steps. One is finding the end of S string, and then from there you keep adding the T string to the end of S string until reaching this end of line symbol, right? All right, please go ahead. Open the file E9-2 and give it a try. All right, I think the implementation is straightforward, although you might see some bugs you need to solve. But here, if you want to make the change from the array version into this pointer version, basically, effectively, you just replace this si by star ps or whatever username is, right? Yeah, star s in this example, because we're just using this one. So yeah, you keep comparing that star s to the end of line symbol until you reach the end of, right? And then you copy them over. Yeah. As long as star p is not the end of line, you increment it, or you can actually move this plus plus over here as well, right? And then you assign this t to the p incrementally until you reaching this end of line in the t value, right? All right. If you look at some old C program, you might see that some of this some of the pointer are not assigned with a type, which is quite risky. For example, here, save a string, and in this case, the type of this function is not given, and by default, again, this is old style. By default, the function, if you're not giving the type of the function, it will by default return integer. While we're returning a character. So it might actually work because a lot of systems treat integer and the character the same. But then in not guaranteed. In some systems, it's not always the case. The only time we want to do that in the previous example is if we're reading inputs from the user, right? In that case, we always save them as integer. So in the modern system, what we can do is we can use this void pointer. The void star and then with your function name after. The void pointer will allows you to cast your pointer to a genetic type. So it doesn't matter if it's a character or integer or double pointer after. You can always use this one. It does give you a lot of flexibility, right? Because you don't need to worry about the type of this pointer as a return of your function. Okay, so before we wrap up, one more knowledge we want to talk about is this multi-dimensional array. So we only talk about the one-dimensional array for now. Now we want to talk about the multi-dimension means, for example, 2D or 3D array. Note that in C, you can define either rectangular multi-dimension array, means every row will have the same amount of column. You can do that. Or so-called ragged array. Ragged array means not necessarily every row will have the same amount of columns. So you have the choice. So here is an example of a multi-dimensional column, which is 2 by 13, right? So this means 2 rows and 13 columns. And by define, this is the definition how you create this type of array using the 2 curly bracket. Right? The bracket inside contains each row, and then they stack up into a 2D array. So by the way, what this table do is it stores the number of days in each month. All right. So you might ask, okay, but there's only 12 months, why it has 13 columns? Right. This is just for easier mapping. Let's say if I'm retracting the day of month 1, so I can essentially call either 1 or 0, and here I can put them months here directly, right? If it's a month 1, it means the second column. Month 2, third column, so on and so forth. So I don't have to do the add 1 or minus 1 operation. That's the only reason. So let's see how to use it. Let's say we want to make a function which will give you year, months of the day, right? And what it do is it will calculate how many days has been passed on that particular day of the month. Right? Let's say if we're passing February 15th, so it will add the total amount of days in January on top of the number of days in February. So add it up, tells you the total amount of days so far in the year. The reason it needs the year information is to figure out if it's a leap year or not. Right? Leap year has different days in February. So that is also why we have the two column in the table. One is for the normal year, first row, second row is for the leap year. So this makes our function very efficient by having the 2D array. Then we can here using this leap to determine which row we're going to call from our 2D array. And then again, the I is determining which months we're talking about. Similarly, we can convert, right, the year day into the actual day of the month. So those two functions are examples where we can use the 2D array for conversion purpose. Okay, so while we declare array of 2D array, we want to use the square bracket twice, like I and j separately. Yes, yeah. You can add more if you want a 3D array, right? You can add more. But know that's different from the other language like Python. You will have them inside the same bracket. Right? So that this is the difference. Yeah, here is how you pass it to a function. This is the one way you can pass. You have to pass the size of the array when you pass it into a function. However, you could omit the first one, which is the number of rows. You can leave it open. That is okay. Alternative way is to using this expression. That's do the same thing, all right? So we'll talk about more on this expression in the next lesson, right? But just for now, remember they're the same. All right, so today we have talked about pointer, how to get address from the value, how to get the value from the address, how to use them in your function, how to increment it, decrement it, what's the relationship and pointer and array, and how to list a few useful functions using the pointer, or we convert them from the array version to the pointer version. All right, next time we'll continue on this part. I will see you guys on Thursday.